Hello and welcome to IGCSE Mathematics 0580 Extended Course, Syllabus Topic E1 Number, Module 1 E1.6 Inequalities. This is part 7. In this part, we're going to solve exercise 16 of chapter number 5. As you know, we are using Complete Mathematics for Cambridge IGCSE Extended Syllabus written by David Rayner. And for your reference, we are going to solve question number 35 onward of exercise 16, chapter number 5, and it's on page 193. Okay, so in question number 36, it says state the smallest integer n for which 4n greater than 19. So you have to find out the smallest value of n, right? So the question is 4n greater than 19. So first of all, we will make the x alone. So we divide 4 on the other side. So it is n greater than 19 over 4. 19 over 4 is almost 4.75, right? So if you draw it on a real line, this is your 19 over 4. It means that greater than means this number is not included and you have to move towards the right side of 19 over 4 because n is greater than it. And then it says state the smallest integer n. Smallest integer n, of course, 4.75 or 19 over 4 is not an integer and it's not included even, and you have to move towards the right. So the smallest integer will be 5 here because after 4.75, because this number is 4.75 and the next integer, the whole number, is 5, so the n is equals to 5. This is the smallest integer for which n is greater than 19 over 4. In question number 40, it says find the value of p such that 9 less than 2p plus 1 and 2p plus 1 less than 11. So now in this inequality, we have to find the value of p. So let's see what the inequality says. It says 9 less than 2p plus 1 less than 11. So once again, same methodology, we will divide this inequality into two inequalities. So we will write 9 less than 2p plus 1 like this one. Another will be 2p plus 1 less than 11. So now we'll move 1 onto the left side. So it will be 9 minus 1 less than 2p. So it will be 9 minus 1 is 8, 8 less than 2p, and we will take 2 on there, it will divide there, so it will be 8 over 2 less than p, or 2 fours are 8, so we can write like p is greater than 4. It's the same thing if it says 4 less than p or p greater than 4, that's the same thing because the mouth of alligator is towards p, it's the same meaning. Now in here, in this case, we have to move this plus 1 on to the right side, so it will be 2p less than 11 minus 1, so it means it will be 2p less than 10, and 2 is multiplied here by taking on the right side, it will be divided, so it will be p less than 10 divided by 2, and it will be p less than 5. Now see, we have two inequalities, p less than 5 and p greater than 4. If we want to draw it on a number line, it's like that. Of course, the same methodology, the smaller number on the left side, 4 is on the left side, is smaller, and 5 is on the right side, which is bigger, and both are greater than less than. It means the 4 and 5 themselves are not included, so we put an open circle on it, and it says p greater than 4, so it means we have to move towards the right, and here it says p less than 5, so it means we have to move towards the left. It means our required result lie within 4 and 5, right? Then it says find the value of p, and it means that by looking at this, we can say that 4 is less than p less than 5, or p is squeezed between 4 and 5. So this is the value of p. Now it could be anything, 4.1, 4.2, 4.9, 4.7, but strictly speaking, the p must be between 4 and 5. Okay, so in question number 40, when it says find a simple fraction q such that, now what's the condition? 4 over 9 less than q less than 5 over 9. So we will use the same methodology. We'll divide this inequality into two parts, this one and this one. So it will be 4 over 9 less than q, or we can say, simply speaking, q greater than 4 over 9. And 4 over 9 is almost equals to, we can say, q greater than 0.4, almost 0.4 something, right? And here take another inequality, says q less than 5 over 9. So it means that 5 over 9, it's almost equals to 0.5, because 9 5 to 45, so it is 0.5 something, right? We just need the first decimal place, and that will do. Now see, q is squeezed between 4 over 9 and 5 over 9. It means that q is squeezed between 0.4 and 0.5, and 0.4 and 0.5 are not included themselves, and it is the area in between it. And now look at the question. It says find a simple fraction. Simple fraction, first of all, take out the number out of it. What is lie in between? With 0.4, 0.5, let's take another in between. Let's take the middle part. So the middle part will be 0.45. That number lie exact lie. You can take any of the number. You can take like 0.41, 42, 43, 0.46, but I'm just here taking 0.45. So this 0.45 actually satisfies this inequality because it lies within 0.4 and 0.5. Now it says simple fraction. Now to change into the fraction, we know the methodology. We draw a line. Instead of this decimal, we'll place 1, and there are 2 decimal places, so we'll pay 20 here. So you have 45 over 100, and now you can just make it a bit more simplified. So 5 9s are 45, 5 2s are 10, and 0. So you have an answer of 9 over 20, right? So you have an answer of 9 over 20. Now you can take any other thing. You can take even 0.41, so it will be 41 over 100. This is one of the answer, or you can take 0.42 and so on. So it's up to you. Whatever you take, it will be right, as long as the number you're taking must lie between 0.4 and 0.5. In question number 43, it says state the largest prime number z for which 3z less than 66. So you have to state the largest prime number z, and the condition is 3z less than 66. So of course we have to make x alone, z alone. So we'll take 3 on the other side. It will be divided there. So 66 over 3, and it is 3 2s are 6, 3 2s are 6, 22. It means that z is less than 22, right? Now on a real 9, let's say 20. This is 22, and because it's not included, so it is an open circle. It is less than, so it means you have to move towards the left side of it. Now see, the statement says state the largest prime number. And the largest prime number, of course, we will take the immediate left to the 22. 21 is not a prime number, right? So 21 option is gone. Then 20 is not a prime number, is gone as well. Then comes 19. Now 19 is a prime number, and it is the largest. Of course, after 19, the next prime number will be 13, but 13 will not be a largest. So 19 is the answer. So z is equals to 19. In question number 44, it says find a simple fraction r such that, and you can see like r is squeezed between 1 over 3 and 2 over 3. So we will do the same technique, 1 over 3 less than r, and r less than 2 over 3. We divide this inequality into 2 inequalities like this one. So it means that one says r is greater than 1 over 3, another says r is less than 2 over 3. 1 over 3 means it is 0.3, right, and something, and 2 over 3 means 0.6 something, right? So on a number line, if you draw it like that, smaller number on the left side, which is 0.3 here, and 0.6, which is a larger number, is here, right? 0.3 is we are taking as 1 over 3, and 0.6 we are taking as 2 over 3. Because they are not equal to, it's an open circle, and our answer lie in between them, because it is greater than 0.3 and it is less than 0.6. So our answer lie in between 0.3 and 0.6. Now in here in the question it says find a simple fraction. So it means that you just take any number. Let's suppose I take 0.4. So if you convert 0.4 into fraction, it will be, in place of dot you place 1, and there is one decimal place, so you place 10. So it is 4 over 10. So 4 over 10 means 2 2s are 4, 2 5s are 10. So 2 over 5, one of the answer. But you can take any of the number. Let's suppose if you take 0.5, still in line between. For 0.5, it is 5 over 10. So 5 2s are 10. So the one other answer could be 1 over 2 as well. So as long as you take the number which lie in between 0.3 and 0.6 and change that decimal number into fraction, and that will be your answer. In question number 45, it says find a largest prime number p such that p square less than 400, and we have a square here. For a moment consider, instead of this inequality we have equal sign, p square is equal to 400. So we take the under root on both sides, and the answer will be p equals to, it's a plus minus, whenever you place under root it's a plus minus, so the answer is plus minus 20. Just keep this answer in mind, that p square is equal to 400. The answer is p is either plus 20 or minus 20, because plus 20 into 20 makes 400 and minus 20 into minus 20 makes positive 400 as well. So it means that you can have the value of p either plus 20 or minus 20. Now once you open up this inequality, you have two answers, plus 20 and minus 20, and we have already talked in detail, if you remember, that the answer of p will be in between like this one, minus 20, less than p, and then less than of 20p, right? So because if you see the previous questions, we have discussed in detail how we're going to open this square, and that makes sense. Just keep in mind, whenever it is square less than or greater than, you will have change into two inequality, one with the plus will take the same inequality like this one, and negative you will invert the inequality. Here it is p less than, but for the negative minus 20 you will say p greater than minus 20. Now we will, of course, will later on, now we will solve with the same technique, that the p is squeezed between minus 20 and plus 20. So it means that if you take a number line, smaller number on the left side which is minus 20, bigger number on the right side which is plus 20, and look what it says, find the largest prime number, and they are not included itself, but 20 is not a prime number, and after the 20, because we're taking the largest, so you take immediate left of 20, so after 20 it is 19, and 19 is the prime number which is the largest. By the way, we have another prime number here, 13 as well, then we have 11 as well, but then we have 7 as well, but they're all smaller prime number. Here in the question it says largest, so the answer is 19, so p equals to 19. In question number 46, it says illustrate on a number line the solution set of each pair of simultaneous inequalities. So whatever the solution we have, of course we have two simultaneous equations, one is this inequality, other is this inequality, and we have to combine effect, we have to see the combined effect of these pair of inequalities on a number line. Right, so let's draw it on a number line. Let's suppose draw it first this one. Let's say this is the number line. The x is squeezed between minus 3 and 8. So this is our, let's suppose this is minus 3 and this is our 8 here, right? And these are included as well. So it's a dark here and it's a bit dark here, right? Let me change the color so you can see clearly what the area is. So it means that this dark area and this is also a dark area, and the area is included in between them, like this is the area, right, between them. Now look at this inequality. Let me change the color this as well so you can just see it clearly how it goes. So in here it says x less than 6, so 6 is here somewhere. Let's suppose 6 is here somewhere, right? And here is less than, and it's not equal to, so it's an open circle, and less than means you have to go towards the side. And see, we have to see the common of these two, red and this blue. Common is of course from here to here, this is the common, and of course 3 is included in this inequality, and minus 3 is included in this inequality. This is minus 3, so it is from minus 3 to 6, and 6 is not included. 6 is included this one, but 6 is not included this one. So it will be like minus 3 and 6 on a number line like this, and minus 3 will be a dark because it's included, and 6 is open because it's not included, and everything in between them. So this is the solution set or the combined effect of these two inequalities. In the next video we'll see the part B onward, so see you there.